Welcome back. I am Michelle Plough. In this video, we will discuss sample preparation for the micro-CT. The micro-CT can be used to image a wide variety of samples. Unlike many other procedures, it does not destroy the sample. This makes the micro-CT a very useful technique to analyze samples that are very precious and rare. In the next segment of this video, Ariana will be presenting. She is a graduate student at Duke University. Ariana will discuss her samples and show you how she prepares them for imaging on the micro-CT.
Today I'm scanning a number of fossil bones from ancient primates called Homomyoids. They were relatives of modern-day monkeys, apes, and a primate group called the tarsiers. These fossils are from more than 50 million years ago and were collected in the Badlands of Wyoming by paleontologists from the University of California Museum of Paleontology. Scientists are interested in studying these Homomyoids because they were one of the first true primates, and studying their anatomy can tell us about what kind of animals they were and how they lived. Studying ancient fossil primates can ultimately tell us about how primates separated and evolved from other mammal groups. I scanned the fossils in batches of many bones per scan. I put many fossils into one of these small containers, essentially just empty pill caps, and placed up to 4 pill caps in a single straw. Because each fossil bone comes with a unique specimen number used to track what it is and where it came from, it is important to make and create a careful map of the specimens before I pack them. The reason why we use pill caps and straws is because the specimens are very small, and you want to get them packed in as tight of a space as possible so that we can zoom in as close to the fossils as we can while scanning. These materials, in addition to the cotton used to surround the specimens, are all much lower density than the fossils, which help them stand out during data processing. I also put many fossils in each straw because I have hundreds of fossils to scan, and scanning them one at a time would not be very efficient. This is another benefit to using the micro-CT. Large batch scans can be done without sacrificing the quality of any individual specimen. Each pill cap with a fossil is filled with the cotton, which is used to keep the specimens separated from each other and to keep them from shifting around during the scan. Unintentional movements of the specimens while scanning will ruin the quality of the CT scan and make it blurry. Each straw is then placed in a glass vial with some clay around it so that it's easy to position the straws right in the middle of the scanner stage. The straw is held in place by the clay to reduce any vibration from the stage that might lead to unintended movement of the specimens.
Many types of samples can be analyzed in the micro-CT, not just bones and fossils. Our instrument has been used to image USB drives, electronic circuits, museum specimens, marine species, plants, and meteorites. Sometimes, the samples need to be altered to get the best outcome with the micro-CT. An alteration to a sample may be as simple as taking them outside of any liquid in which they may be in, such as ethanol or formaldehyde. Removing the liquid component will help decrease the noise in the acquired images. Because micro-CT creates images based on the density of the sample, very dense items such as rocks may not produce good images. Removing any unnecessarily dense features of the sample, whether metal screws, rocky matrix, or thick packaging, will also improve the scanning outcome. Similarly, samples must have areas of different densities to produce good images. The best resolution is achieved when specimens are packed in a low-density container that spins tightly around the center of the stage. Orienting the longest dimension up and down keeps parts of the sample from being cut out of the field of view when the sample rotates around 360 degrees. Opting to stain soft tissue samples with a solution of iodine, for example, can increase the level of detail detected by the micro-CT. Here is an animation of a tree shrew from a museum collection. It is about 15 centimeters long. This shrew has been treated with an iodine stain in order to perform a virtual dissection. Without ever cutting into the specimen, the researcher can visualize muscle and soft tissue details inside the shrew that are highlighted by the stain. Thank you for joining me for this video on micro-CT sample preparation.